Okay guys, so here's section 6.3. I have for video 1 my first example here, but whenever I go into mixed constraint problems, or rather problems where I have constraints that are not just necessarily less than or equal to, we need to make sure that we have all of these conditions met. So a simplex method problem must be written as a standard maximum problem, which means that our objective function must be to maximize, not minimize. The constraints must be of the form less than or equal to my constant. All right, so specifically this. And B must be non-negative. All right, so that guy right here must be non-negative. So I have some tricks to make that happen. All right, if I have something of the form where I have a greater than or equal to sign here, I can replace it with this. All right, now hopefully that means that this number that I have here isn't actually a negative number. So say this was negative 2 to begin with, now this will be positive 2. All right, if I have a constraint of the form equal to, we can put that in as two separate inequalities. All right, I have both, all of the same expression here is less than or equal to b, and all of the same things, but all of these are trying to change to negative now, has to be less than or equal to negative b. So if you think about it, if something is at the same time less than or equal to b, and we're also less than or equal to negative b, it has to be actually just equal to b. All right. So if I were to have something all mixed up like this, and I wanted to write the initial tableau for it, all right, my first one's just fine. All right. Whenever I go to write this as an equation, so I'll write my equations over here. I'm just going to have 3x1 plus x2 plus s1. And I don't have to do anything to it now. I just get 15 equals 15 because this was or equal to. All right. Now, with this one, we don't want to work off of x1 minus 4x2 is greater than or equal to 8. What I want to work off of is what I should replace it with. What I should have replaced this with is, I'm going to leave everything the same, but I'm going to flip the sign and make everything negative. So, negative x1, change the sign, plus 4x2 is less than or equal to negative 8. And that seems almost like it violates this condition, but that b is non-negative, but we'll talk about that later. So this is what I'm going to put into my system over here of equations. I have negative x1 plus 4x2 plus s2, and that equals negative 8. All right. Now from here, this is one of those where I have to replace this with two different inequalities. If I have an equal to here, I can replace it with everything left alone with a less than or equal to sign. So 6x1 plus 5x2 is less than or equal to 7. And also making everything negative and flipping the sign. So negative 6x1 minus 5x2 is less than or equal to negative 7. All right, so when I put both of those into my list of equations over here, I'm going to get 6x1 plus 5x2 plus s3 equals 7. I'm going to get negative 6x1 minus 5x2 plus s4 equals negative 7. And I can finally go ahead and put my maximization function in. That's going to give me, we'll just go ahead and write it down here, negative 4x1 plus 3x2 over here plus z equals 0. Okay? So if I were to solve this problem, I would want to put all of this into my tableau. I'm going to have 3 1, 1. And I have to make sure I have S2, S3, S4, Z all in there. So 1, 2, 3, 4 zeros. And finally, I have 15 over here. All right, for this row, we have -1, 4, 0, 1, 0, 0, 0, -8. I've got 6, 5, 0, 0, 1, 0, 0, 7. I have -6, -5, 0, 0, 0, 1, 0, -7. And finally, we have -4, 3, 0, 0, 0, 0, 1, 0. So there is my initial tableau. And of course, if I were going to maximize, I would actually need to pivot. But all we're asked to do there is to actually write my tableau.